The universe is vast. It's filled with billions of galaxies. Each galaxy holds billions of stars. Could our sun be the only star with a planet like Earth? Could our planet be the only one with life? These are questions that have intrigued humans for centuries. We long to know if we are alone in the universe. The search for exoplanets, planets orbiting other stars, is our quest to find the answer. For much of human history, we could only imagine such worlds. Our technology limited us to studying our own solar system. But in the late 20th century, things began to change. Astronomers developed new methods to detect planets far beyond our reach. The Kepler Space Telescope, launched in 2009, revolutionized this search. It opened our eyes to the possibility of countless planets, some perhaps very similar to our own. The Kepler Space Telescope was a marvel of engineering. It was designed for one primary goal: to find exoplanets. Specifically, it aimed to discover Earth-sized planets in the habitable zones of their stars. The habitable zone is the region around a star where temperatures are just right for liquid water to exist on a planet's surface. Liquid water is considered essential for life as we know it. Kepler launched into an Earth-trailing heliocentric orbit. This means it orbited the Sun, trailing behind Earth. This unique vantage point allowed Kepler to stare at a single patch of sky for years. It observed over 150,000 stars in the constellations Cygnus and Lyra. Kepler's mission was to watch for the faintest dips in a star's brightness. These dips, it turned out, held the key to finding hidden worlds. Kepler employed a method called the transit method to discover exoplanets. Imagine you are observing a distant star. If a planet orbits that star, and if that planet's orbit is aligned just right, it will pass in front of the star from our perspective. This passage is called a transit. During a transit, the planet blocks a tiny fraction of the star's light. This causes a slight dip in the star's brightness. Kepler was incredibly sensitive to these dips. By measuring the duration and depth of these dips, astronomers could determine the size of the planet and its distance from its star. This information allowed scientists to calculate if a planet might be in the habitable zone. Kepler's mission was a resounding success. It far exceeded expectations. It discovered thousands of exoplanet candidates, greatly expanding our knowledge of planetary systems beyond our own. One of Kepler's most exciting discoveries was Kepler 22b. This planet was one of the first confirmed to be in the habitable zone of a Sun-like star. Kepler 22b is larger than Earth, earning it the nickname Super-Earth. Its discovery fueled our imagination about the possibility of finding life elsewhere in the cosmos. Although Kepler's primary mission ended in 2013 due to mechanical issues, its legacy continues to shape astronomy. The data it collected is a treasure trove that astronomers will be analyzing for years to come. Kepler's discoveries revolutionized our understanding of the universe. It showed us that planets are not rare but rather quite common. It opened our eyes to the possibility that we may not be alone. Kepler's legacy is a universe teeming with possibilities, a universe ripe for exploration. Our quest to understand our place in the cosmos continues, inspired by the discoveries of this remarkable telescope.